if we need to use implicit, how do I get rid of a natural log?
E.
Okay, let's E both sides.
What do you mean?
So you have e to the y equals e to the natural log of x. What do we know about e to the natural log of x? It becomes what?
X.
So you have e to the y equals x. Okay, what's the derivative of e to the y?
E to the y.
Times
Derivative of y.
dy dx, which is derivative of y. What's the derivative of x?
Dx.
1.
Or 1.
So we want to solve for dy dx, which means we need to divide by e to the y. And this is where like the answer was in terms of y on your paper. If I wanted my answer to not be in terms of y, y is equal to,
So it's 1 over e to the 1.
but e to the ln of x becomes,
X.
Wait, why did it become e to the ln x again?
y is
Oh.
ln x. So we substitute ln x in for y. And then the e's and the ln's cancel, so you get 1 over x. Therefore, the derivative of the natural log of x is which I believe is your next slide. Or your next spot on your paper, right?
S, B, and C.
Okay, seriously, what is
I don't know. I opened the window, were ringing, and I was scared I like set off.
That's the boiler thing.
Oh yeah, we hear that with or without the window.
Yeah.
With
Yeah,
the-
I guess it sounds kind of loud.
That's because it's directly below us outside. Yeah, like when you, if you, I've walked out that door at like the end of the day, it's so loud. All right.
That's actually the cause of locker room showers being ice cold every day.
That's
All right.
That needs to be a short
No,
skit.
it's not.
Just like if e was raised to a function, if the natural log has a function, did you miss? So the second part of your notes is 1 over x. The third part is this, which is the derivative of the natural log of u, where u is a function,
So
equals 1 over u times du dx, or u prime.
hold on. Go back, John. What is that? Where is that? We did that.
Yeah, but it's the derivative of f of x equals ln x is then
1 over x.
1 over x. And then it says the derivative of f of x equals ln u, where u is the function you made 1 over u times du dx.
Or you.
Like this slide here is this one. I just wrote out more for you. So, what that means is we need to look at problems, evaluate what this is. So the inside function is my u.
It's actually 1 over u.
The derivative of x cubed plus 1 is, so the derivative of y in terms of this is dy dx equals 1 over u, which is x cubed plus 1, times the derivative of u, which is 3x squared. So the derivative is 3x squared all over x cubed plus 1. And you're done.
Oh, this is actually easy.
Okay? What is the inside function? Derivative of sine is? So the derivative of y is 1 over u, which is sine, times derivative of u, which is cosine. Cosine over sine is, I don't know why it started to write t. Oh, I just wanted to write t. Okay. And the fun continues. This is a square root.
Ew.
Oh,
Oh wait, would you just put it all?
Boys, we got him.
Like put the 1/2 in front of everything. I'm wrong.
This is like a chain rule.
Yeah, so you put
Yeah.
1/2 in front of the whole thing, and
And
then
then
do the
Yes.
What? I'm so smart.
I thought you wanted to change that to like a 1/2 power. That's
Oh,
like what you were talking.
No.
So exactly, you will take the derivative of a square root, which is 1/2, all the inside stuff, to the negative 1/2. So the inside stuff is the ln of 2x. And then you multiply by the derivative of the inside. So derivative of the natural log of 2x is 1 over 2x times the derivative of 2x, which is, so look what happens. Yep, your 2's cancel. This negative 1/2 would drop to the denominator with our 2. So it would be 2 square roots of natural log 2x. And then the x would also stay in your denominator. So it'd be like 2x. And your numerator would just be a 1.
That wasn't bad.
Wait, why do we still have to oh,
Do we come any farther than that? Or can you teach me?
Can't do anything to it.
I don't know if my
Why
eye
can't you?
is a pencil.
What?
Why can't you do that one?
What would you do to it?
Turn it into that's why I'm like different. That's what I'm saying.
You can't do it. There's nothing you can do. Like, there's no algebra trick to fix that.
Then why could be like the beginning?
What?
Like I thought it was the fun stuff.
Okay, repeat your question.
I don't know what my question is.
Okay. I don't know how to give you an answer then. I don't know what you're asking.
Oh,
Destin.
How dare you?
I'm supposed to go then.
well, George.
Is that supposed to go to George? Are you attacking George?
What did you throw?
All right.
It was like a cellular.
So, the inside of this is relatively gross because the inside derivative would be a, yes, hooty high hotty ho kosher roll.
Try to do it in my hand.
So, my suggestion and why we started with algebra and pre-calc review and not straight derivatives is that I would apply those rules to this problem. So what do you know about a natural log that is being divided on the inside?
Oh,
You can split it to what?
Alright, hold on. Yeah, that means.
Doesn't mean you did it wrong. It just means you didn't do it as easily as you could have. What do you know about a square root? It is raised to the, yes. So if that's like the 1/2 power, what can you do to a power of a natural log?
Am I the only one that sometimes writes L-I-N instead of just L?
Yes.
All the time.
Right, L-I-N?
Yeah, like I don't know why.
If it's troubling for you, you could do these in cursive.
Oh, that would be even more.
Oh, what?
Yeah.
I do that.
What?
It
That's
looks
how I
like
write
a
my
4
L's.
7 or something like that. I'm trying to look at
Well,
it.
you're a
Is it just
Okay.
maybe some people write it as A?
What is the
The
derivative of the natural log of x plus 1 then becomes derivative of x plus 1 is
1.
so it doesn't matter, minus 1/2 derivative of the natural log of x minus 2, which is 1 over x minus 2. Derivative of x minus 2 is 1. So we get 1 over x plus 1 minus 1 over, distribute that 2, so you get 2x minus 4. Or you could have just had 2 quantity x minus 2. I just distributed my 2. I assume we don't want to see how to do it if you didn't split this.
Yeah, no, I'm good.
It's very gross.
Don't even bother. I tried and
Yeah, it's gross.
You won't get this answer.
Okay. Oh, did I do it the long way? Maybe. Yeah, I did. I did do it the long way. Like that's the hoodie high and hoodie ho stuff.
Oh, at the top it says the same as one.
What?
At the top is the same as the one we just did.
yeah, but she did it.
Yeah, I did it both ways. Like last year, they must have wanted to see. They didn't.
Yeah, we don't.
Here it is!
Okay. The log of a to the u is always 1 over ln a times 1 over u times du dx. What does this look like in here?
Chain roll.
What does the derivative? What does this derivative piece look like? The derivatives we've just been doing, right? This looks like the natural log of u.
Which technically is.
What is the log of a to the u if we use change of base?
L log a over log u. Ln a over ln u or something like that.
Yeah, you kind of got to know it. What's the change of base formula?
Ln a over ln u. Or is it ln u over ln a?
Wait, change of base?
And all your notes on them?
Wait, isn't it log ln a over ln u? Right.
Everybody, we've had
I
two.
flipped it.
We have
ln x over ln u over ln a.
Oh, son of a gun.
everybody had it flipped except for George.
Oh, it was just ice.
So it should be the natural log of u over the natural log of a. What is the natural log of a? What does a represent?
Why do we keep
The
writing
base,
these?
but is it a number or a function?
It's a number.
So this is kind of like saying 1 over the natural log of a, which is kind of like 1/2, 1/3, it's a number, right? Times the natural log of u. Derivative of the natural log of u is 1 over u du dx. So if you forget the derivative of a log, you can use change of base if you do it correctly and get the derivative using change of base. What?
Nothing. Can you go
See,
back to
I
that?
jumped my gun.
Well, can you go back to that then?
I'll just go write it on here.
I don't know.
Or I'll just undo my deleting. There you go.
ln x over ln a.
There you go. So it's ln u over ln a. And that becomes 1 over ln a times derivative of ln u. Just 1 over ln a times 1 over u du dx.
Base formula.
Yes.
You know what the LN
True.
or example 3?
Yes.
Like, the answer for 2 is just coding, right? Like just
Right. Because the ln's in the answer for 3 because it's under the square root. The square root encompassed the ln.
And if it wasn't
If
square
the
root,
ln is on the outside, then the ln's go away. If the ln is on the inside, the ln
yeah,
stays.
Okay. Just like you said, they kept doesn't simplify.
Okay.
Oh,
All right. Differentiate then log base 10 of 2 plus sine x. So remember, it's dy dx equals 1 over the natural log of the base, which is 10, times 1 over the function, which is 2 plus sine x, times the derivative of the function. Derivative of 2 is, derivative of sine is. So this becomes cosine x over the natural log of 10 times the quantity 2 plus sine x. This is where parentheses are super important. If you do not have the quantity 2 plus sine x encompassed in them, it is not the same thing.
Is that all the way done?
That's all the way done.
Like, I wouldn't take 1 over ln.
No, you're done.
But could you?
No.
Oh, gosh, no.
That's what I keep saying. No. Yeah. I know. This is like the problem we saw today with the 10 to the 2 square root of 2x.
Okay, I just did this in the wrong spot, so it wouldn't
Oh.
This is example for on.
We just did example 5.
This is the one after. Yeah. Okay.
You are.
This is not example 5. This is the derivative of an exponential function with base
The
a.
one after.
What's on the screen now is right after. Oh, wait, what?
It literally goes to where we just went. Like, what's so difficult?
You did it right. You copied it the right spot. Okay, you're
My
done.
notes today are apparently messing with your brain. Okay, a to the u. A is a number. U is a function. Function. So it's a to the u, kind of like e to the x, or e to the u. That repeats. Times natural log of a, so that a is still always an ln of a number, times derivative of the u, du dx. So a to the u du dx is just like the e to the u, but now because this is an e, it's the natural log of a. Do you know why we don't have the natural log of e? Like, this is still the same as the e to the u. So let's say this. What happens to this piece that we really see every time but we don't know it? Becomes 1, right? So a to the u is identical to e to the u. It's just that we don't teach you this step here because it goes away every time. But, oh my gosh. But do you see the rain stuff? Do you see how these are identical? That e is a constant, a is a constant. They mirror each other. It's just I let you kind of ignore it. Okay, 10 to the 2x. So dy dx equals 10 to the 2x, just like it's the same as e to the u, times derivative of 2x. Derivative of 2x is
2.
times the natural log of a, which is the natural log of 10.
Funny? Oh, you're right. Yeah, right.
Wait, do you leave it like that?
Derivative of
Yeah,
2x is u.
Is that how we're leaving it?
So Josh really likes to simplify things, right?
Pretty much.
What can you do to 2 ln of 10?
2 base 2.
That's
2 base, or ln base 2. No. ln 10 squared.
Oh, you know what? I was thinking that. Then I'm like,
Is that really
no.
simplifying though?
Yeah, that's not simplifying. I'm leaving it as the above list.
Why? It becomes the natural log of 100 then.
See above though. That's what you need there. I'm keeping it at the top.
All of the above.
Hey, you're the one who always wants to simplify. I gave you an opportunity.
Because I want to see every answer possible in case
Well, there's 3.
He saw all the possible answers now, and he chose to not like it.
That's how this should work. What, so it'd be less because I want to
But we're gonna do whatever this is, because that's what I did.
What do you need essays today?
Wednesday, Schreiers, Friday.
Because I haven't even got
There's 3 essays.
Should I do that? Should I start applying?
a Schreier. Don't plan a Schreier. Don't be like beforehand.
Be normal.
That's what everything is.
Don't be one of those weirdos.
Holy.
Harlan says they're all
Yeah.
So
I
now
must
we're
have
gonna
had a reason for it.
Let's go 13 to 27 and 35
This guy,
to 41.
Are they all even? So just the.
This
Everything
guy.
is even.
This guy. Wait.
This
This
guy.
guy.
Alright, Josh.